So ladies and gentlemen, on this question we are asked to reduce the following trigonometric expression. All right. So before we start, I need us to discuss some of the important things about this Cartesian plane. The Cartesian plane, we draw it from 0 to 90, 180, 270, and 360. Anti-clockwise, it's positive. Just remember, anti-clockwise, it's positive. So you can just show the positive. Obviously, you'll know that the negative is the opposite of the anti-clockwise, which means clockwise is negative. Awesome. And then remember here, all of them are positive. Sine is positive, tan and cos is positive then. And then let's see, ladies and gents, we are going to do this. If we are starting on the y-axis, we are going to change. So sine becomes cos, cos becomes sine. But if we are starting on the x-axis, we stay the same. If you had sine, you stay as sine. If you had cos, you stay as cos. And then if the angle is negative, just add 360 to it and then do the normal reduction. Right. So that said, the first part, we have 90 plus. Okay, let me just write my half there. And then we have multiplied by, so I'll put a dot. 90 plus, we are in the second quadrant, right? So cos is negative in the second quadrant. So we know that is negative. But because we started on the y-axis, 90 is on the y-axis. So we're going to switch. The cos will now become sine because we started on the y-axis. Then we're going to have minus sine theta. And then we have minus 90. Remember I said if we have minus, you just say minus 90 plus 360. That's like having 270. So you have 270 plus theta there basically. Do you see it? 270 plus is in the fourth quadrant, and cos and sine is negative in the fourth quadrant. So I'll say negative. But because we started on the y-axis, the sine will now become cos of theta. Remember, if you're starting on the y-axis, so which means if you're working with 90 or 270, you are always going to switch because those are on the y-axis. If you're working with 180 and 360 and 0, you do not switch. Right, perfect. And then let's divide now. A square, it's always positive. So I have cos squared 180 minus. 180 minus is in the second quadrant. Cos is negative there. But because we have a square is always positive. And 180 is on the x-axis. So I'm not going to change. So it's just going to be cos squared theta then. Right. Negative theta is like you have a 360 minus. Remember I said if you have negative, you add. So we're going to add 360 to that. So it's going to be 360 minus theta. 360 minus, obviously we can see it's in the fourth quadrant, right? Because 360 plus would be in the first, so 360 minus is in the fourth. And in the fourth quadrant, cos is negative. It's positive. So this will just be, okay, let's write the negative 2 first. That will just be cos of theta because we're in the quadrant 4. And then there we have 90 plus theta. This is 90 plus. So that is in the second quadrant. But because we have a square is always positive. So the sign won't change. But because we started on 90, the cos becomes sine. So we're going to have sine squared theta. Right. And then now let's further simplify this. On top, we're going to have negative half sine theta. Negative sine times negative cos will give us positive sine cos theta all over sine squared and cos squared add up to 1, right? Sine squared theta plus cos squared theta will always give you 1. It's an identity. Minus 2 cos theta, right? And then on top, I can factorize. After changing identities and reducing, always factorize. So that becomes sine of theta, right? And then actually let's take the half out as well. I'm going to take the negative half out. So negative half sine theta is the common factor. Here we're going to be left with 1. And then because we're taking a negative, we're going to have a minus there, so that negative and negative will still give us that positive. All right. So now there, because we have 1, we're going to say 1 divided by half, that gives us 2. Ne? So that when we multiply, we will still get the positive 1 there. All right. So in terms of numbers, you just divide them. Ne? Good. And then we're left with cos theta, because sine is out, all over 1 minus 2 cos theta. And we can see, ladies and gents, that this and that will cancel. So our final answer, I don't like showing the cancelling so that my works remain neat, but I just cancel it in my brain. So that is the final reduced answer, ladies and gentlemen. Thank you very much.